Alright, this is going to be a sort of short topic on polyatomic ions, but they're so important that I wanted to make it its own video. So we've talked already about the fact that atoms can gain or lose electrons to become ions. But not only can atoms do this, but so can covalently bonded molecules. And so a molecule that gains or loses electrons and acquires a charge, we call that a polyatomic ion, right? Poly, the poly prefix meaning many, so this is a many atom ion. And polyatomic ions can pair up with other ions of the opposite charge to form ionic compounds. And so this is a list of some common polyatomic ions. There are many more than this, but these are very common ones that we'll encounter quite a bit over your chemistry careers. And so I can't stress enough how important it is to learn these polyatomic ions. I know it seems like a lot, but your work will be paid off because a lot of the things that we'll do in the future, both this semester and next semester in organic chemistry, analytical chemistry, any other classes that you take, you have to know these polyatomic ions because they come up so frequently. And when you're learning the polyatomic ions, you need to know their names, you need to know the formulas, and then you also have to know the charges. The charges are just as important, if not more important, than the formulas and the names. Now, you don't have to write all of these down right now. I'll have handouts of these on D2L. I also have a Quizlet that you can use to practice these, but I can't stress enough how important it is. But if we go to the next slide, I think I have some tips that can reduce the number a little bit, and so it's not quite so many as the 23 that you see pictured here. So there are some patterns that you may notice when you look at the polyatomic ions that can help kind of reduce the number a little bit. And so if we look, for example, at the chlorate ion, it has a formula of ClO3-. If we look at nitrate, it's NO3-. And sulfate is SO4-2-. So you can see that just because it ends in ATE doesn't tell me how many oxygens there are, right? Chlorate and nitrate both have 3, sulfate has 4. So we have to be a little bit careful, but the prefixes and the suffixes of the polyatomic ions are always similar. And so, for example, when we go from chlorate down to chlorite, I lose an oxygen. The charge stays the same. I go from ClO3- to ClO2-. And the same thing happens with nitrate. When I go to nitrite, I lose an oxygen, NO2-. The same thing happens with sulfate. When I go to sulfite, it becomes not 4, but 3, 2-. If I want to go one less oxygen, I add a hypo prefix. So hypochlorite would be ClO-. You don't encounter this very often, and this isn't one of the ones that I want you to know, but if we had a hyponitrite, it would be NO-, or a hyposulfite would be SO2-2-. And if I go up one, right, the chlorate was ClO3-. If I had a pernitrate, which I'm not sure actually exists, but if it did, it would be NO4-. Right, and there is no persulfate, so we don't have to worry about that. But if we remember the relationship between, right, as long as you know chlorate, you know chlorite will have 1 less oxygen, the hypoite will have 2 less oxygens, and if we know the 8, the per8 will have 1 more oxygen. Another pattern that you'll notice, a lot of the polyatomic ions that have not just a -1 charge, but more than a -1 charge, they also have a paired ion that has a hydrogen added to it. So carbonate is CO3-2-, hydrogen carbonate is HCO3-. Right? Similarly, phosphate is PO4-3-. So then hydrogen phosphate is HPO4, and when we add the hydrogens, it loses one of the negative charges, and so as phosphate is -3, hydrogen phosphate is 2 minus. And so as long as you know the 8s, and you remember these other rules about the per-8, or the ite, or the hypoite, and then what happens when we go from the polyatomic ion to the hydrogen polyatomic ion, this actually takes the number of polyatomic ions that you need to know from 23 down to 12. And so that's even a little bit more manageable. But I can't stress enough how important it is to actually get these memorized. And I know professors always hate to say you got to memorize this, to say you got to know it, you got to learn it. No, in this case, you just have to memorize these polyatomic ions. You have to know them in order to be successful in this course. Alright, and so the last thing I want to do, and again, we'll do more of this when we do nomenclature, is just to predict the formulas of some ionic compounds that contain polyatomic ions, just like we did with the monatomic ions. And we can do this when we know the charges of the metals that they're paired with, or because we always know the charge on the polyatomic ions. So if I was going to combine sodium ions with phosphate ions, well, sodium is an alkali metal. And so if you look at your periodic table, you would know that sodium has a +1 charge, and phosphate has a 3- charge. And so when I combine these ions together, the ionic compound has to be neutral, and so I'm going to need 3 sodiums to counteract the -3 on the phosphorus. So the formula for sodium phosphate is Na3PO4. Alright, if I do the ionic compound formed between barium ions and nitrate ions, well, barium, if you look at your periodic table, is an alkaline earth metal, so I know it's going to be +2. If you look up nitrate in the table, it's NO3-. So for every 1 barium, I'm going to need 2 nitrates in order to make that compound neutral. And so when we have multiple polyatomic ions, I can't just put a 2 down here, because that would be confusing. It's like, is it 32, or what are we writing? So when I have more than 1 polyatomic ion, what I do is I put it in parentheses. So I have 1 barium, so the whole formula for the polyatomic ion would go inside the parentheses. So the whole nitrate is in parentheses, and then I want 2 nitrates to make it neutral. And now when we're counting atoms, if I asked how many atoms were in 1 formula unit of barium nitrate, well, we have 1 barium. The 2 applies to everything in the parentheses, so I would have 2 nitrogens, and then 2 times 3, I would have 6 oxygens. Alright, one more example. We want to do ammonium sulfate. So ammonium is a little bit unique. Of the polyatomic ions that I want you to know, ammonium is the only one that's positive. And the ammonium polyatomic ion is NH4+. Sulfate is SO4 2-. So the ionic compound formed between ammonium ions and sulfate ions, I would need 2 ammoniums for every 1 sulfate. So I would take the ammonium and put it in parentheses, and then the sulfate. And if you'll notice in all my answers, right, in the final formula, there are no charges, because the ionic compounds themselves are neutral, even though they're made up of ions.